Thanks for having me here. It's a real honor to be here, and thanks for the introduction. My name's Derek Slater. I'm a policy analyst at Google. I work on our public policy team supporting our government affairs and advocacy efforts around the world, primarily focusing on broadband and copyright policy. Our introducer was a little too generous. I was not there with Vint Cerf when the internet was invented. We don't have a fountain of youth at Google. But I am fortunate to get to work with a lot of engineers, because I work here in Mountain View, to work with them to help shape our advocacy efforts and also work with them on projects, on tools that can help advance effective internet policy. And my slides were in the other folder somewhere. And I'm going to talk to you about a common theme of the day, which is data. The importance, particularly of broadband data, both in understanding the current state of broadband networks and figuring out how to do the research to make a quantum leap forward to the future of broadband networks. And I'm right there. That's fine. As we already heard this morning, and we'll hear from Blair more, we know that broadband is of the utmost importance to our economy, to our society, to us as individuals, as speakers, as citizens, as consumers. The thing is, there's still lots of information gaps when it comes to understanding broadband as it is today, and also how we get to a world where there's faster, universal, affordable, and open broadband internet access, and ensuring that that's the case. The broadband plan has a lot of key parts that help fill in pieces of the puzzle, but there's still a lot that we have to learn. So I'm going to tell you about two projects. The first project I'm going to tell you about is called Measurement Lab. And it started with what I consider to be a foundational question at the heart of every internet user's experience, certainly mine, and I'd say most people's. It's a very simple, straightforward question I think Ward was asking himself this morning when things went a little haywire. And when I'm at home and I'm using an internet application and something doesn't work, something's going slow, the connection's flaky, or just isn't working right, what's the problem? Is it the computer? Is it the application? Is it my wireless router? Is it my broadband connection? And one of the things today is that consumers really, when they sign up for broadband, have a very hard time of knowing exactly what they're paying for. What's the actual speed? What's the latency? What are the congestion conditions typically? How do network management practices affect certain applications? And so on. It's not transparent to the user. I think it's also it's a broader issue than that. And certainly because of how important broadband is, it's a much more important issue than, say, consumers not being able to set the time on their VCR, right? This is much more paramount that consumers can make well-informed decisions in the market. It's also important for researchers, for innovators, and for policymakers that we have good aggregate sense of what is the performance of broadband networks today, so the policymakers can make good decisions, and so we have the sort of research that advances broadband and the internet. So we started with that focus a couple years ago. Vint Cerf and a group of Googlers, including myself, invited some network researchers to campus to ask them, how can we help you do better network measurement, better broadband measurement, and how can we help you help users? And what they told us was, well, look, before the internet was commercialized, we had access to lots of great data. Now there's a paucity of data. And we lack some of the infrastructure to do measurement, and we also sort of operate in silos, such that when we collect data, it's hard to share it with one another. Somebody publishes a paper, but then the data is thrown away and it can't be built on and reused easily. So we said, okay, we can help with that. And so we started this project, which we launched in January 2008, called Measurement Lab. It's a distributed open server platform that network researchers can use to deploy broadband measurement tools. And these are the sorts of tools where a user can click a button and run a simple test between them and a server and get some sort of result about the speed of their connection in that test, latency statistics, whether certain applications are being shaped or blocked, and so on. There are 5 tools currently running on the platform, all developed by researchers around the world. So users get information about their own connection when they run these tests, and also researchers get data as well that they can then analyze and contribute to our broader understanding. Measurement Lab, or MLab as we call it, is an open platform. It's open to other researchers to join, other companies and institutions. All the tools are open. That is, their source code is published so people can validate and verify and improve the methodology. And all the data is open, available for people to reuse under public domain license so that they can take it and incorporate it into their own research. And you can go to measurementlab.net and check out the tools for yourself. As I said, this is a collaborative effort. We started this by talking to the research community, and there are researchers around the world that are leading this project with the support of not just Google, but a number of other companies, including Amazon, Samknows, which is a UK company that's now provisionally working with the FCC on a measurement project, the New America Foundation, and others. And in a relatively short amount of time, we've had some success in getting a healthy data pool for researchers to start analyzing. There are now 5 tools, like I said, on 45 servers in the US and Europe. The distributed nature of the platform is important to getting robust measurement. 6 million tests have been run. There are about 30 terabytes of data, and you see this spike here at the edge. That spike corresponds to 2 things. One is a partnership with BitTorrent Inc. that makes an application to share large files. They incorporated one of the tools into their platform so that people could do speed tests and measure their connection. So they were building on top of that tool, building on top of this platform. It also corresponds to when the FCC built on top of the same tool to collect more data. So the FCC, as part of their national broadband plan, released this consumer broadband test in early March, even before the release of the plan. They used both a commercial provider, Ookla, who runs speedtest.net, and the network diagnostic tool on Measurement Lab, which was created by Internet2 and is used by a variety of institutions, including Verizon in their speed test for files. The FCC published the initial results 1 week later. And what's really cool about this partnership, I think, is that what the FCC did was, again, built on top of this platform, this open platform created by researchers, to create a simplified user interface for users, to give them some straightforward information and try and create a bit of insight for them. Again, it's a first step, and the FCC is taking more to make this sort of information even clearer and more robust. But by giving users a way to do this test very easily, it's also creating a lot more richer, more detailed data for researchers to work on. This is part of what a researcher sees from the data set that's being created. These are the measurements in a given speed test in 5 millisecond increments. And there are lots of other variables that are recorded. The reason this is important is because it gives researchers the ability to see not just what the result of the test was, but look at why the result was reached, what factors were impacting the result. So not just why the user got, not just what the speed of the user's connection was, but why did they get that speed? What was the bottleneck? Was there something on the computer's end? And so on.